it's time to do the actual assignment for 6.6 part 1, which was solving exponential equations. Now, you have this idea out there. It's a theorem. It says if you have a base to some exponent x, and it's equal to the same base to a y, then x equals y. And this is sadly something that requires number sense. Now, what you have to do is you have to manipulate your bases. 36 can be written as 6 squared, and 1 over 6 can be written as 6 to the negative first power. You know, I've tried to get some of y'all to do this, but go to 6, raise it to the negative 1, hit math, answer frac, 1 over 6. The issue is entirely number sense. Anyways, that particular number right here already has an 11 minus an x in the exponential space. So here's what I've done. I've established this theorem. I've established this idea, this common sense theorem. I'm literally going to take the 6's and I'm going to throw them away. Maybe this thing will do what I'm telling it to do. I'm just going to pretend they're not there anymore. So now I have a line that says 2 is negative 1 times 11 minus x. And I'm just going to do basic math, man. I'm going to use that distributive property. I'm going to add 11 to the other side. 2 plus 11 is 13, and there is my x value. It's not a hard theorem. And that's the only one I'm doing in that group. Looks like I'm doing 2 of these. So I'm not doing magic here, kids. I know that 5 to the second power is 25. You're supposed to know that. Everybody who lives is supposed to breathe that. 1 over 125, I don't know what the decimal looks like, but I also know that since 5 cubed is 125, 5 to the negative third has to be the same thing. So that's how I'm doing the rewrite process here. I've got 25 becomes 5 to the second. There's already a 10x plus 8 there, so notice I'm just writing it back down and wrapping the set of parentheses. 2 or more things we wrap. 1 over 125 is going to be the negative third power. And there's already a 4 minus 2x up there. Now I establish my theorem. My theorem says once you get the bases the same, you throw them out the window. You hit it with the double, sorry, I'm jumping ahead for some of y'all. Throw them out the window. Hit it with the double distributed property, 2 times 10x, 20x, 2 times 8, 16. And I said double, singular distributed property. On the right-hand side, we have a negative 12 plus a 6x because negative 3 times negative 2 is positive 6. We're going to move things around. We're going to get our x's on one side. We're going to isolate x. And I'm going to be doing this. It's going over here. And this is going over here. 20 minus 6 is 14. And negative 12 minus 16 is negative 28. I end up with a nice, pretty x value of negative 2 when I do the division. And I know for some of y'all, I'm probably not showing enough work, but that's all that's needed. I'm not going to spend an hour doing a video. All right, 81. So that 81 is 3 to the 4th. Number sense. So the common base here is 3x minus 7. 81 is 3 to the 4th. And again, there's already a 12 minus 3x sitting up pretty in the numerator. I get to say 3x minus 7. I'm going to do 2 steps here. 4 times 12 is 48 minus 12x. And I'm actually going to shift my x's to the right. No, sorry. I'm going to shift my x over here. It's going to make it positive. And I'm going to shift that number over here, which is also going to make it positive. 3 plus 12 is 15. Boy, I just got tired. And 48 plus 7 is 55. X would be 55 over 15, which reduces down to 11 and 3. Fractional answer. I don't think I made any mistakes. Moving forward, here we have logarithms. So what we're going to do here is we're going to isolate the base first. And to do that, I'm going to take that little guy right there and I'm going to put it over here. I'm also going to switch over to pen. Do we need to be doing fractions, by the way? Well, we don't have to. We can use decimals, they're just kind of ugly. But whatever, we'll just use decimals. Y'all don't like fractions, you're afraid of them. But anyways, if you don't know what 4 plus 0.25 is, I pray for you daily. It's 4.25. Just showing you. 0.5 to the x equals 4.25. I go through and identify my base. It is 0.5 or 1/2. I would really prefer you use that. My exponent was x, and my answer is going to be the 4.25. It would be nice if you said 17 quarters. It would. You know, if you're wondering how I did that, it's because I understand fractions and decimals, but math, enter, 17 quarters. Anyways, but with y'all, I'll just use decimals. You're going to have a logarithm, and her base is 0.5. Her argument is 4.25, and she equals x. And then we're going to use change base. I know that a log of base b argument a, and I like the LNs, I told you that in class, is ln a over ln b. So I'm going to have the natural log of 4.25, sitting pretty over the natural log of 0.5, and that's my x value when everything is said and done. And I'd be happy if you stop there. It's going to be a negative number. And she's negative 2.0875. See if I can remember that, negative 2.0875. Double squiggly means about. 10. I'm going to do kind of the same thing here. I'm going to do these baby steps. 5 minus 16 is negative 11. Divide out the negative 3. So e to the 2x is 11 thirds. I would not convert that into a decimal because it'd be a repeating decimal. I'm going to identify my base. My base is e. Its exponent is, oddly enough, 2x. And the answer to this particular equation is 11 thirds. And I'm going to do this. I'm going to do log is bay. So she is a log whose base is e. Her argument is 11 thirds, and she equals 2x. Log base e is better known as the natural log. And I divide by 2, and I have an answer. I use technology, and she will tell me what said answer is. There's the natural log of 11 over 3, and I'm supposed to divide it by 2. 0.6496. It's not too bad. And what you're going to see on your next test is there's going to be a large chunk of you who understand logarithms. You've tried every single day. You'll do well. And then there's going to be those of you who just have not tried. I don't know what it takes. 15 is, since we're dealing with exponential equations, you may as well learn how to solve something like this. I have a hint there. It's called let u be 5 to the x. This is actually known as the u method. Why it's the letter u couldn't tell you. You let u be something funny or odd looking, make the equation look better. So I am letting u equal 5 to the x because u squared would be 5 to the 2x. Notice the introduction of the square there. 2, 2, 2, 2. So here's a 5 to the 2x. It is going to become u squared. There's a plus 20. There's 5 to the x, which is u. And we have minus 125, and it equals 0. And now what I've done is I've created something that factors or is more apparent. This factors. My brain is screaming at me 5 and 25. 5 times 25 is 125, and 25 minus 5 is 0. That's what my brain is screaming at me right now. So, time to write it. U and a u to make a u squared. I need a plus 25 and a minus 5. And then I use the zero product property. U plus 25 is 0, or u minus 5 is 0. So u is equal to negative 125, or u is 5. And then I go back and I do substitution. 5 to the x equals negative 125, or 5 to the x equals 5. And by the way, that 5 has an understood exponent of 1. So this one's easy. This is x equals 1. This particular problem is easy if you understand numbers. So let me write that out somewhere. Five to the negative x is equal to negative 125, is easy if you understand numbers. And since none of you do, show the work. All right? You got to show the work. Your base is 5. Your exponent is negative x. And your answer is negative 125. So I have a log whose base is 5. Her answer is negative 125. And she equals negative x. That's supposed to be a 5 there. I do my conversion, natural log of negative 125 with an ln of 5. And I go push some buttons in a TI-84, and I'm not going to be surprised. This calculator is about to tell me that I have an imaginary answer. Error non-real. So this is literally x DNE does not exist. So while I'm on this thing, like, why was this an issue? The domain of any log or a logarithm that has an argument, the argument is bigger than 0. And you know, think about the graphs. You cannot throw anything smaller than 0 because there's a vertical asymptote at 0. I hope that makes sense. I'm going to do both of these, even though 17 is the only one that's highlighted. How does the graph of f of x equals 3 times x minus 2 squared plus 1? There's a couple of different transformations here. There's that 3. And by the way, here's your work. You show. It's not just to pick one. 3 is a vertical stretch. Probably should pick a better different color here. Vertical stretch. It's going to show up well. Blue? Yeah, and it's all pretty bad, isn't it? There you go. I see x minus 2. That is a shift right 2. I see a plus 1. That is an up 1. Now, a stretch is going to make something taller or skinnier. I don't know if I spelled skinnier right or not there. But anyways, I see the word wider. I see the word wider. Gone, gone. What do we have? Right 2. Notice that? Left 2. Up 1. Narrower. It's got all the keywords. This particular question stolen from a New York Regents exam. Now, here's what's cool about New York. Their Regents exam is basically their EOC, but if you failed EOC in New York, you failed class. Be glad y'all don't live in New York. All right, 15. What are the zeros of the polynomial? Have you heard of factoring by grouping? I don't know if you have or not. I have. I'm going to set the thing equal to 0. I notice that the first two terms contain an x squared. The last two terms contain a -9. Notice I saw x squared right there. I know that 45 is divisible by 9. I've got the common factor of x minus 5, and I have the remaining pieces of x squared minus 9. And I can factor x squared minus 9 quite a bit more. It's x plus 3 and x minus 3. This will give me x is 5, -3, or 3 by using the zero product property. And the answers make sense, by the way. And I'll talk about this one. It's multiple choice. You may as well learn how to test. Does God love some of you? I have positive 5. That one right there. You know, just go to your calculator, take a 5, store it to x, push the frickin' equation in, man. X cubed minus 5x squared. You know, sadly, the people that I want to watch this video won't watch it. You know who you are. You're not going to watch. I could probably talk all the crap I wanted to. If I had my webcam on, you could see the sheer disappointment in my face. That's a 0. I got a 0. Take a -3, store it to x. Arrow up. Bam, a 0. Take a 3, store it to x. Up, up, up. Bam, a 0. Just push buttons, children. And that, boys and girls, is that. Good, because I'm tired.